start with a very short, sweet introduction. I'm Sreerupa Dutta Audito. I am a business analyst with ThoughtWorks.
Hi everyone, my name is Priyanka Rawat and I'm working as a business analyst with ThoughtWorks. I've been in industry for over 7 years now. With ThoughtWorks it's 2 years. So before we begin with the presentation, I'll just set a small primer over here. We'll talk about big data, some existing technologies, some challenges that we as a BAs face in handling big data, and a little about a small problem statement on machine learning. Hope it goes well. Yeah.
Great. Okay. Stuck. Well, while that kind of goes on, so before we get into the topic, we start delving into the topic, one quick trivia for all of you. Any vague idea as to how much data are we generating as we speak right now? Okay, yes, very close. What is that intensity looking like? Any idea? Okay, so by 2020, which is right now, we are generating close to 1.7 MB of data per second per person on the earth. That's the quantum. Now, what does that mean? That's 1 zettabyte of data almost every single day. If I were to quantify it further, what does it even look like physically? So 1 zettabyte is 10 billion petabytes. What is a petabyte? Let's take a step down further. Now I'm going to throw a physical example here. We've heard about Amazon rainforests. That's 1.4 billion acres of lush green vegetation, lot of trees. If I were to chop all of those trees, and I don't want to, I love my environment. If I were to chop all of those trees, convert all of those trees into paper, fill both the side of those papers with text in every inch of it, that's 1 petabyte. So imagine doing that 10 million times with the Amazon rainforest. That's 1 zettabyte. That's the quantum of data that you're generating every day. But how did we manage to get this big? So data that we are generating is getting generated from every little swipe that you make, that little button click on the app, the searches that you make, the purchases that you make. Of course, there's laundry list of, structured data. You're streaming Netflix, Amazon Prime, and there's this laundry list of other platforms. Everything is data. To top it all, data comes in different shapes and sizes. Really, what do I even mean by that? So broadly classified, data could be structured, semi-structured, and unstructured. While structured data is your typical databases, semi-structured is your JSONs and XML feeds, and then you've got unstructured data, which is like audios and videos. So that's where we are. But going forward, some history here, data isn't a beast that we are trying to tame only right now. It was back in 20th century, government of USA was struggling to deal with contributions from various citizens, and punch cards were an answer from IBM to that problem. 1970s saw the advent of relational databases, and SQL for data was growing and storage was extremely expensive. Come 1989, computer scientist Tim Berners-Lee invented www. Little did he know at that point in time what impact will it have on the data. And since then, data has grown exponentially. It has grown to that enormous size where physical machines are no longer enough to hold that data or even crunch it. And thus that gave rise to distributed computing and distributed storage. 2005 saw Hadoop coming up, promising that it could do amazing job with humongous amount of data, right? What complicates it further is the 3 V's of data: the velocity, the variety, and the volume. So what's that ever exploding volume of data? What are the different varieties of data that you have to solve for in a given problem space, and at which rate is it coming to you? All of that is the big data problem space.
So we talked about big data, but what role does a business analyst play in this world? It's an important question. Any answer? Correct. But is that so easy to seek inferences? It becomes a challenge for us. So let's consider one example. I guess most of you must have seen cricket matches. What happens there? There are 2 teams which are competing each other. And what they do before they go out for the play, they go and study their opponents. They look for their strengths, their weaknesses, the kind of tactics they use when they go out with other opponents. Why do they do that? There's just one simple reason: because they want to study, they want to analyze their opponents so that they can be better prepared for the game. Just like that, each decision maker or a BA or a data analyst, before going to big data, has to analyze the problem itself. And that's where we say data analysis is important. So what is data analysis? Just like its name, it's a process of analyzing data sets, get information out of it, and most importantly, understand the problem statement. Because there is a lot of data which is thrown out there, but the important aspect is, do you understand the problem statement? Because at times, what happens, you don't have the problem statement itself. All you have is the data. But this doesn't come easy. You have a lot of challenges that comes with it. One being finding right signal. So how often has it been easier for you to find inferences in big data? Because there is a lot of lump of data which is out there, but finding that noise and the right signal becomes very difficult. The next challenge that we have is in terms of storage. We say this data is big, it is getting generated at a very massive rate. Like Sreerupa just talked about, big data has 3 characteristics: volume, variety, and the way it's getting generated. But we also have to take into account, do we have those existing technologies and storage to store this data? There we say we have some data storage technologies, like you have data lakes, you have data warehouses. But that's not enough. The complications come when you have data like structured or unstructured data. And imagine a situation you have unstructured data, it's coming from various sources and you have to integrate them. It becomes a challenge. The next challenge is finding right technologies, which is very much linked to right storage itself. You need to have a right technology, because there is a lot of technology which is out there. Everybody now wants to move to cloud solutions. But is it that easier? No, because at times the migration itself becomes a painful thing. You have to rewrite all of your things because systems have been on-premise, and moving to cloud isn't that easy. Seeing options like EMR and Hadoop, even from Hadoop to EMR at times becomes a challenge, because there are latest versions that keep coming, and to upgrade yourself into that is a difficult task. So there we say your tech architects play an important role. They have to decide right technology that suits your problem, and you have to determine what kind of data are you dealing with. The last one, which is data silos. Various times what happens, people say, or I must say, organizations say that we are storing our data. The data coming from customers, the data coming from the browsing history. But the problem which lies there is the data is in separate and disparate units. If I have to go there and analyze some patterns like why are my customers dropping off, I can't do that. Why? Because my data is not integrated. So the more silo your environment is, it becomes a challenge because the gaps would be widened over there. So we need to actually work on these challenges. Yeah.
So having understood an overview of challenges that we tend to face in this world, the very first challenge that you have is to identify the problem. And problems in this space are often not apparent. They are buried deep inside the data. So with an example, during this talk, we'll try to take a stab as to how do we define that problem statement at a very business analyst level. And to do so, I will need a volunteer, or maybe two, and I'm going to put you guys into a spot just for a moment. So, your name? Neem.
Don't be afraid, it's going to be fun.
Yeah. So, Neem is driving his luxury car on a highway. He has to attend a friend's wedding. It's a new car, just about a year old. Mood bright and sunny because I'm going to my friend's wedding, and the car breaks down. What would be your immediate reaction?
You're all dressed up.
Sorry?
Like the roadside assistance
Yeah.
from the car company.
So that you will seek help, but what would be your immediate reaction?
Like my car is not working.
Your car is not working.
Yes.
It's a new car. I've
It's a new
spent
car.
enough on it, right?
Yeah.
I must
Yeah.
have been very frustrated. Yeah.
Ma'am, your name? Aruna runs a service center for a luxury branded car. She enjoys immense good customer feedback, but there are times of the year where this quotient drops significantly and she gets bombarded left, right, center. What would be Aruna's reaction to that?
To the call that he would make to me?
Yeah.
Or generally that I'm overwhelmed with the number of calls coming in?
Yeah.
Again, frustrated.
Right.
Frustrated and overwhelmed. Right.
Frustrated, overwhelmed. So if you see, these are just symptoms. They are symptoms of a problem. What if the car could tell Neem and Aruna, I need repairs. I need repairs before you can think about it.
All right, so we have just introduced one problem that my car is asking for a repair. There is one perspective that we saw from the car operator. There is one perspective that we saw from the manufacturer or the service center itself. All right, let's try to dug into this problem itself. So, like we asked you that what would have been your first immediate reaction when you see a breakdown? You said, I'll probably call a service center or a roadside assistance. Generally, what happened in a normal case scenario, if my car has broken down, I would not rather go to service center first. Reason being, it's gonna be a little costly for me, and maybe they might not be immediately available for me. I would rather look out for a mechanic. That's gonna be a little cheap, will not take me much time, and I'll get my things done. But there are pros and cons for both the systems, right? Because if you go to local mechanic, you're not sure whether if he or she installs any part on the car, is it going to be a good one? It may break down again. And if you go to service center, you might not expect very immediate response from them. So, having said that, we know that we have to look out for these people. It would have been good if some way my car would have sent me some response or some signal that I needed a repair. Let's also see what generally happens in a day when such a situation occurs. You go to a service center, the serviceman guy looks for the car, does the servicing. At the end of it, what he does, he records some data. Some data like, for example, let's consider that my car has run 3,000 miles as of now, and my car has these static rules that every 3,000 miles I need a repair, or maybe a common servicing that we say every year. I go to a service center, get it done. In the end, the serviceman record this 3,000 miles as minus 30. That is possible because it's a human error and we all are prone to mistakes. Now, what impact would it have? Instead of writing 3,000 miles over there, he made a mistake of writing 30 or maybe some other number. Any idea what impact it's going to have? All right, I'll tell you. So, your future servicing depend on the data which is entered by the serviceman. So, instead of reporting another servicing on 6,000 miles, the calculation would start from minus 30 now. That disrupts the whole servicing. And it generally happens in most of the cases because serviceman is not only waiting for you, he's dealing with many customers in a day and he's prone to do those mistakes. So one single customer doesn't affect him. To make it more complicated, you must have seen, since we all are so busy in our day, when we go out, when we take our car for servicing, we generally end up doing a lot more things on them. We get an oil change, we get a tire change. So if you have to think from a systems perspective, you have to come up with a solution that can take care of these combinations and permutations of job. All right, we'll move ahead and see more. So we'll just talk a little more on data collection. So first was the manual entry that the serviceman is making, which we said is prone to errors. There is another way the data gets collected, which we say sensors. I think most of you must have heard about these telematic systems. These are installed in our car. So what sensors generally do, whenever your car is driving or maybe not driving, they send these data to the car manufacturer's system, or they may be maintaining some third-party systems. So at all time of day, your data is getting recorded about your vehicle's health. And they try to make sure that whatever state your vehicle is in or any part of your vehicle is in, it gets reported and can be further analyzed. We don't say that go by the sensor vehicle approach, but what I'm trying to convey is these sensors can be helpful for a problem that we just talked about, which is predictive maintenance. Also, it's not correct that sensor usually sends the right data. Sensors can also send you incorrect data, because we have seen cases where sensors are actually small boxes. These sensor boxes can actually send you random data like 999 or maybe 000. They can also actually disrupt your calculations. So we cannot entirely depend on sensor as well. We have to come up with something that's a combination of both and can give us a right calculation for the servicing. All right. So let's take a step. We collected data. We said that we're getting data from servicemen, we're getting data from sensors, but they are prone to error, which means after data collection, we also need to do data cleansing. That's a very important step. I took an example, like my car has run 3,000 miles and my serviceman, while reporting the data, made an incorrect entry like minus 30. Imagine I get this data and I am analyzing it, I see this entry, I can clearly say that this is not reality because nothing can be minus 30 as a distance traveled, which means that I need to clean this data. How do I do it? Can you guys think of any way of cleaning this data? All right. So cases, you wanted to say something, sir? All right, I thought you're waving hand. So cases like this needs cleansing. Cleansing in a way, probably, maybe you can assign some default values to them. Maybe convert negative to positive. At least you'll be in a right figure, if not in an incorrect figure. So data cleansing is important, but there is a lot of data which is out there. How do you determine which one is relevant for me? It's a difficult task because considering your problem statement, not all of data would be important to you. So there, we have to look for important features. And these features are actually, could be your color of car, the fuel that your car is using, its manufacturing date, or maybe the geographical region where the car is getting driven. So, machine learning actually came into existence to solve problems like these only, where you do not have to group any manual strategies. It could just read data and work on the parameters or features that you're providing. I'll not go into the algorithm part because that's actually the data scientist where they come into play. But what we as a BA can suggest what could be those important features. There is this one algorithm which is like not the best one, but one of the good algorithms. You have a question?
Like you are saying, we can do the feature engineering to get the features, but with the deep learning thing coming into after machine learning, do we really care about extracting the features because my neural nets will already do it for me?
Yes, that's what I was coming to. Even a random forest takes care of features as well. So what you can do is, you can provide your data and your features to the random forest algorithm where it itself randomly selects data and features, even ranks them based on some metrics and tells you what are the important features, where you actually don't have to look at feature level, which is very similar to what Sir has said. So like I mentioned, random forest, I'll just not go at random forest level. So random forest is actually a mix of decision trees. And I'm sure you guys are aware of decision tree. It's a tree that is a representation of a decision that got taken because of the questions we asked or we provided to the system. For example, what color my car is it red or blue? So you throw a question and then you get an answer. Similarly, random forest is a group of these small decision trees, and it goes to a greater depth depending on the number of features you're taking. And it randomly itself decides which features are the best. So it doesn't only go after just one tree. It takes into account numerous trees.
So, having a gist of it, if we were to tie back the problem, how did we start? We articulated the problem from a bunch of symptoms. We heard about the symptoms and we articulated the problem. We tried to acquire data for it, and this is where your tech team starts coming into picture. Data acquisition is an elephant by itself. There could be variety of data at different velocity, different sizes. You have to choose the right technology to be able to acquire that data. The very next step is to be able to kind of cleanse the data. But before cleansing comes into picture, as BAs, you are often required to do something called an EDA, which is exploratory data analysis, where you would look at this lump of data and you would try and figure out if a particular value in an attribute makes sense. So suppose I have a column that says age and the value is 201. The oldest man by Guinness Book of World Record, we lost him very recently, was aged 112 years. So 201 is very far from reality. Given this kind of research, you have to come up with bounded context. You have to figure out boundaries for each and every lump of data. Given that, once you have identified, what is the cleansing mechanism, your tech team pitches again, figures out ways to clean that data based on the business rules that you supply. And here comes a data scientist. The job of a data scientist is now to study this data and figure out you've got these 500 odd attributes. Are they equally important for the problem space? If yes, what is the weight of each column? And then come up with an algorithm. Like Priyanka explained, random forest is one algorithm that's hugely famous in this space. But come up with an algorithm that suits this problem space, and then run a series of experiments. You train your model, you run it on an actual data, receive feedback, understand if the results were helping the problem, transmit that feedback to the model, train it again, and this cycle kind of continues. And your predictive model, day in, day out, gets better. Moving ahead. So machine learning, we just saw one example. There are many other fields in which machine learning can come handy and solve. It's being used in healthcare. One of the key examples is, very recently I read, IBM, along with a bunch of healthcare units, they are coming up with some sort of a predictive model that can predict onset of Parkinson's and onset of Alzheimer's as early as 10 years from the real visible symptoms. Isn't that great? So there's variety of domain space where machine learning could be applied. Can we move ahead? Had we applied predictive maintenance to Neem's problem and to Aruna's problem, we wouldn't have landed up here. Imagine your car dashboard, the screen that you have telling you, hey, your scheduled maintenance was maybe 6 months from now, but I feel something is wrong with your engine, or there's something wrong with your tire pressure. You may want to visit the service station in next 2 days. To Aruna's problem, because she's receiving the data to and fro, she knows when a surge is expected, she can plan for capacity, and the satisfaction quotient never goes down. So that's the world that we are talking about. Can we move ahead? So what we are trying to say here is, based on stats, if we just concentrate on this problem statement, machine learning could be leveraged to reduce maintenance cost up till 40%. There could be 50% reduction in total vehicular downtime. Now this is just one problem statement and one example where we leverage data and machine learning to solve it. Imagine the quantum of impact when it is applied to diverse stages. Thank you.
We still have 5 minutes left, I think.
And we would be available till the afternoon today. So if you have more questions, feel free to ask. Thank you.
Thank you, guys.